Hello students, we are now looking into another application of LPP in operations domain. It is called as workforce assignment. So if you can read this, it is a frequent problem which in front of production managers in making decisions involving staff requirements for a given planning period. Workforce assignments often have some flexibility, and at least some personnel can be assigned to more than one department or work center. Such is the case when employees have been cross trained for on two or more jobs. For instance, a salesperson can also be transferred between the stores. So you can see that first we need to give them cross training, means training into more than one department, and slowly involve them into those that work also whenever the need arise. So the problem in front of us is here. McCormick manufacturing company produces two products with contributions to profit per unit of $10 and $9. The labor requirements per unit produced and total hours available from personnel assigned to each of the four departments are shown in the table. Assuming that the number of hours available in each department is fixed, we can formulate McCormick's problem as a standard product mix linear program with following decision variables. So we can start doing this with let P1 be the units of product 1 in that product mix, that is optimum product mix. Let P2 be the units of product 2 in the optimum product mix. Now from given this information of the number of hours required per unit and the total number of availables with each department, for example, department 1 has 6,500 hours available, 2 has 6,000 hours available, and so on. So we can formulate those constraints and our model will look like this: maximize 10P1 plus 9P2 subject to, this is department 1 constraint, 0.65 P1, 0.65 P1 plus 0.95 P2 less than equal to 6,500, and so on. And finally the non-negativity constraint that P1 and P2 should be greater than equal to 0. Now this is without the cross training. This is a plain problem, but when you have a cross training, which they have given here, this is the information. This is the standard problem, but now we are going into cross training. So this is the information where from department to department you can transfer some people because they are now cross trained. So from department 1 to department 2, yes, the transfer is possible. From 1 to 3 is possible. From 2 to 3 and 2 to 4 is possible. From 3 to 4 is possible. From 4 to 1 and 4 to 2 are possible. And maximum how many you can transfer from department 1 is also given here. 400 maximum is possible. From department 2, 800 maximum is possible. Basically this plus this should not exceed 800. Department 3, 100 possible, and department 4, 200 possible. Now the author has introduced separate variables BI, and then it becomes little bit more complicated. So instead of that, I have a very straightforward solution to this. So I'm just showing you here that problem. So this particular information is given. The objective function will remain the same, that we want to maximize 10P1, that is contribution of the first product and contribution of the second product, we want to maximize. Now let Tij be the number of hours transferred being transferred from department I to department J. So if you consider this one is T12, this one is T13, like that. Then for the first department, see, we already have 6,500 hours. So our total hours will now change to 6,500 plus whatever are transfer are happening within to the department, and minus whatever transfers happening from the department. So if you look at here, from our first department, 1 2 is going to be coming to department, uh, 2 department. You have to look at a 2 department. So for department, from 4 to 1 will come, right? Whatever is coming is, you have to look at the columns. So this one is coming to 1. So T41 will be added, and what is going is from here. So T12 and T13 are going out. So the first department's equation becomes, this is the same left side here, and this available hours only now will change to get modified to 6,500 plus T41 which is coming inside the coming to the department, minus T12 and minus T13 which is going from the department 1 to 2, 1 to 3, right? So this is how we will write these 4 equations with new departmental hours available based on the cross training, right? Also they have given here that maximum hours transferable from department 1 are 400. So T12 plus T13 should be less than 400, T23 plus T24 should be less than 800, and so on. So these are the 4 additional constraints for the maximum hours transfer limit from the departments. And as usual, we will write the all my variables. So my variables are Tij. So 1 2 3 4 5 6 7 are my additional variables. B1 B2 B3 B4 I am not using, and then the P1 and P2, all these variables should be greater than equal to 0, non-negativity variables. So when you solve this into the Excel solver, you will get this answer here. So you can cross check whether you are getting the same answer after the cross training. See, they have clearly mentioned here. So now the answer is here, all these answers. So this is your answer. So just cross check whether you get the same answer. So actually the new cost will be 73, sorry, new volume, the revenue will become 84,011. So there will be an increase in the revenue because of the cross training by 10,421. So this is your workforce assignment problem along with the cross training. Thank you.